Okay, how are we doing here? This is Mike Johnston, and in this video we're going to discuss something that is near and dear to many of our hearts, and this is called the quadratic equation. This is the quadratic equation. And the quadratic equation is something that many people have discussed in many other math courses, and they range from calculus all the way down to algebra, and people see them forever and ever and ever. And they also range in many other STEM courses like chemistry and physics. So this is something that will follow you forever. So it's important to understand what a quadratic equation is. So I know the first thing I like to do is I like to define the standard form of a quadratic equation. So I like to define the standard form of a quadratic equation. And when we say standard, this is usually the most common form that we see. However, it is not the only form we can see. So a standard form of the quadratic equation is going to be ax squared plus bx plus c set equal to 0, where a, b, and c can exist as any real number, but they usually prevent a from being equal to 0, because if a equals to 0, then you would no longer have a quadratic. So some people say, well, Mr. Johnston, Mike, quad means 4. Quads means 4. I don't see a 4 anywhere here. I see a 2, but I don't see a 4. So why would we call this a quadratic equation? Why wouldn't we call this a biratic equation? I've heard that before. So that just goes to the etymology of the word, and a quadratic is interesting because it's a form of the word quadrate, which means square or rectangular, and the word is actually derived from the Latin word quadratus, which means to make square. So quadratus means to make something square. So a square has 4 sides, so hence the word quad, and that's the reason why we use it in terms of the quadriceps, or if we're sitting in a building and it's called a quad, it's because it has 4 sides. But it actually is determined because of the word quadratus, the derivation, and that means to make something square. So here we have something that is square, and that's the reason why we can call this a quadratic equation, and this is the standard form. We are going to learn that we have also another form called a quadratic function. A quadratic function. And this is very similar to a quadratic equation. However, we just set it equal to a value of f of x. So we just set it equal to a value of f of x. And this is a quadratic function. So a quadratic equation, a quadratic function are very similar in nature. And these other restrictions on the a, b, and c variables also hold true here as well. So I will make a special note. And maybe I'll do it up here in green. A special note is that a quadratic equation must be set equal to 0. It must be set equal to 0. So otherwise, it won't be, not that it's not going to follow the same form, but it's going to be a lot more difficult to solve. So almost impossible to solve. So make sure all of your quadratic equations are set equal to 0. We are going to learn about something later on down the road, which is called the quadratic formula. And the quadratic formula is a way to solve a quadratic equation. Is a way to solve a quadratic equation. However, we're not going to discuss that at this point. We're going to discuss that later on in some future videos. So let us go ahead and discuss some principles. Oh my goodness. Once I start, I never stop. So let us discuss some principles that we're going to use in order to solve some quadratic equations. And these principles are going to be pretty consistent. However, the names do change up from class to class. So this first principle I'm going to discuss is called the zero value principle. This just states, here I go again. Excuse me. Sorry about that. If a times b equals to 0, this implies excuse me. I might have to take a break. That either a equals to 0 or b equals to 0. So this applies that either a equals to 0 or b equals to 0. And this seems somewhat rudimentary for a lot of people. However, let's look at an example and see where we would apply this. So let us say we have the quantity of x minus 2 times x plus 3 set equal to 0. So notice this, excuse me, equation is set equal to 0. I think you're going to hear me sneeze in this video more than me talking. So notice it's set equal to 0, so that's our first check. Now what we can do is that we can split this up into x minus 2 set equal to 0 times x plus 3 set equal to 0. And this implies that x plus 3 will also equal to 0. And we can split this up because of that zero value principle, because we're multiplying our two binomials together. As we're multiplying our a and b together, we can split them up and set them equal to 0. But this only applies if we're set equal to 0. It does not apply unless we're set equal to 0. So now we can go ahead and add 2 on both sides. So we get x equals to positive 2, and then we can subtract 3 on both sides. And over here, we're going to get x equals to negative 3. And I have a little extra or equal sign there, which we don't need. So we're able to solve this simultaneously by setting each of those binomials equal to 0. There is also another principle which we call the square root principle. And I think many of us have actually performed this principle several times, not realizing that we are actually performing a principle, we're actually acting upon a principle. So this states that if x squared is equal to k, and they usually like to describe k as a constant. They like to say k as a constant. This implies that x equals to plus or minus square root of k. So in order to solve this equation, we have to take the square root of both sides, but we have to add that plus or minus. And I have seen calculus students and differential equation students drop off that plus or minus and only leave the plus, and it does make a big difference in the outcome. So let's go ahead and look at an example of where we would use these principles. Let us look at an example of where we would use this principle. So let us say we have an example of 2x squared minus 15 is set equal to 0. So the first thing I'm going to do is that I'm going to add 15 on both sides. And I get 2x squared is equal to positive 15. And then I'm divide both sides by 2. And the 2 cancels over there. We're left with x squared equals to 15 all over 2. But in order to solve, I have to get rid of that square, and the opposite operation of the square is the square root. But when I take the square root of both sides, I have to add the plus or minus. So this implies that x equals 2 plus or minus square root of 15 all over 2. So we're going to get 2 solutions there, and that's indicative of the fact that this is a square term. This square term, or the degree of this equation, will indicate how many solutions we're going to get, whether or not we're going to get 2 real solutions, 1 real solution, or 2 imaginary solutions. So remember, your solutions can be both real or imaginary. So in this circumstance, we have 2 real solutions. Let's go ahead and advance. Let's go ahead and advance one problem further, and let's go ahead and identify a quadratic that we're going to state to solve. Solve 2x squared minus x is equal to 3. So the first headlight incident I have is that I say, oh, no. This equation needs to be set equal to 0. It's a quadratic, and the only time I can solve this quadratic is if it's set equal to 0. So the first thing that I have to do is set equal to 0 by subtracting 3 on both sides. So we're going to get 2x squared minus x minus 3 is set equal to 0. So now we're going to have to factor. We're going to have to factor this equation. So I recognize that I have a 2 as a leading coefficient, so I know I'm going to have factors of 2, and then I'm going to have a 1. And it's an x squared term, so I know this is going to be an x, and this is going to be a 1x. My first side is going to be a negative. What times a negative gives me a negative? And that's going to be a positive. And factors of 3 that are going to give me a -1 are going to have to be a -3 and a +1 because we get the 2x squared. We're going to have a positive 2x minus 3x gives me that -1x. So this breaks down to 2x minus 3 times x plus 1 set equal to 0. And if you need help factoring this rapidly, go ahead and review some of my factoring methods. And there's a couple different ways to factor this question. But as you do it enough, you'll start seeing that it's actually relatively simple. So notice here we are multiplying these two values together. So we can split them up since they're set equal to 0. We get 2x minus 3 equals to 0 and x plus 1 equals to 0. Over here we can add 3 on both sides. And we get 2x equals to 3, and divide both sides by 2, and we get x equals to 3/2. And over here, we're going to subtract 1 on both sides, and we get x equals to -1. So we were able to determine both of these solutions by using a factoring method and setting them equal to 0. So that is going to be extremely helpful for us. But the question is, what does that mean when we solve, when we get this? So if I were to have the equation instead, f of x equals to 2x squared minus x minus 3, this would be in the form of a quadratic function. And before we found those we set this guy equal to 0, and we are able to solve, and we get x equals to -1 and x equals to positive 3/2. So what does that mean? At -1 and positive 3/2, our graph is going to cross the x-axis at these 2 points, and we're going to have a parabola opening up that crosses at these 2 points. These points have several names. The first, they are called solutions. Secondly, they are called zeros. And lastly, a little bit more formal term that we know, we call them x-intercepts. So by setting a quadratic equation equal to 0 and solving, we can determine the solutions, the zeros, and the x-intercepts.